Good afternoon, my name is Will Kellum. This is going to be my final project for ELEE423 sensors and transducers. Let's take a look inside at my final project, the Decker Checker. My patient today is going to be a Gravely ZX52 ProTurn. I'm going to be installing a sensor system, basically like a tachometer, to identify the RPMs of each of the blade pulleys on the deck. I'll be using my Mac to monitor the individual RPM speeds of each pulley on the deck. And I'll also be using it to take an average of all three pulleys that are moving. However, the onboard LED screen will be able to tell us if everything is good, if a pulley is bad, or if our data is skewed and doesn't make any sense. I'm going to be identifying the RPM of each of the pulleys using a system comprised of an Arduino Uno, an LED display, and then a combination sensor called a KY003. It's going to be using the Hall effect sensor attached to the very end of it to identify a magnetic field that's coming off the bottom of the pulley.
Looking closely underneath, we can see that I've super glued a rare earth magnet to the bottom of the pulley here. It is directed so that the magnetic field interacts with the KY003 in the proper way, and as we turn it, the KY003 has an onboard LED that comes on as soon as that magnetic field is in range.
First round of testing, I'm going to be rotating the deck using a drill. This process will be sped up in order to see it quicker. So we received a null on the display for that test. That's because two of our pulleys were 10% outside of the mean, but that's pretty explainable given my unsteady drill hand. Now for the full speed demonstration. So we can see with the first demonstration that all pulleys were spinning at approximately the same RPM, and we've been delivered a dash 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 from the display. In order to simulate debris being stuck between the blade pulley and the belt, I'm going to be pushing against the left pulley with this piece of wood. I'm going to hold it there as all three pulleys are tested in order for this to be constant, but if it is successful, we should see ones being displayed on the display in order to show that the left pulley is moving slower than the other two. Just like a tachometer can be used in a car to monitor the RPMs to see how well the engine is performing, the tachometers could be used on the pulleys to identify how fast everything is turning and compare them to each other to identify if there's a problem with a single pulley or if something's jammed between the pulley and the belt itself. This could also be used in robotics for robotic lawnmowers to identify how high the grass is and whether to cut it higher or lower. So there's a lot of applications that could be used in the future. Thanks for watching.